Alright, and welcome to Area of Regular Polygons, Level 5. Now, in our very first example, we want to find the area of the regular polygon below. However, what's different about this one is that instead of being given the side length, we're actually given the apothem. So let's go ahead and write out our formula. We know that the area of a regular polygon is equal to 1/2 the apothem times the perimeter. Now, in this case, when we're finding this, we know that A will equal 1/2 times, and we know our apothem right off the bat, it's 8, but what we're actually missing inside this problem is we are missing the perimeter. So how are we going to find that? Well, we'll still always start these problems off by using our first step. We want to take this and we want to cut it up into our 5 equal triangles because it has 5 sides. And when I do that, I know that all the central angles around the middle will always add up to 360 degrees. So we'll do 360 divided by the number of sides, 360 divided by 5, which in effect will give us these central angles of 72 degrees. Now from here, we actually have enough information to draw a right triangle. So let's go ahead and start by doing that. I draw this right triangle, and it turns out we're looking for this side right here, so let's call that x. Now we know that our apothem is this right here, which is 8, and I can kind of re-illustrate that right there. And of course, the last thing that we'll always need is that angle. Well, ask yourself, what does the apothem do to that 72? Well, it cuts it in half. And we know that 72 divided by 2 will actually give us an angle of 36 degrees. Now notice we have a right triangle. We're going to have to use a little trigonometry. And let's see, if our angle is right here, then x must be the opposite, 8 must be the adjacent. And let's see, what tangent function, or what sine function, oh my gosh, what function uses opposite over adjacent? And I've already given it away. Of course, it's going to be the tangent. So let's write this out. We know that tangent theta is equal to the opposite over the adjacent. And just filling in our information, we know that we have a tangent of 36 degrees is equal to x, our opposite, over 8. Now, how do you solve these? Well, we always start the same way, by multiplying by the denominator. So times 8, and it turns out that once those cancel, we actually have x already by itself. So what is 8 times the tangent of 36? And if you were to use your calculator, you would find it is 5.81. And that is our missing value of x. But notice that that is only half of one of the sides. So to get to the full side, we'll have to do x times 2, or in this case, 5.81 times 2, which will equal 11.62. Now that is the entire side, 11.62, that we've been missing, and this now allows us to get our perimeter. We know that P will equal 11.62 times the number of sides, which is 5. And so you ask yourself, well, what is 11.62 times 5? And that will actually give us 58.12. And now we have enough information to find our actual area. So use this in your calculator. 1/2 times 8 times 58.12, and of course that will give us 232.48, and in this case, inches squared. Go ahead, pause that, finish any notes that you need. If you missed any parts, rewind it, rewatch it, and let's go ahead and move on to example 2. Alright, here in example 2, we want to find the area of this regular polygon given the apothem of 12 inches. Well, how do we draw an apothem? Because it's clearly not shown here. We put a point at our center, and we're going to drop this straight down to connect with the midpoint of DE. And so we know our apothem is 12. Let's start by writing out the formula for the area of a regular polygon. We know that A is equal to 1/2 parentheses the apothem, which in this case is 12, times the perimeter, which in this case we actually don't know what the perimeter is yet. So let me just kind of draw an arrow here saying, hey, we are going to find the perimeter. What is that? Well, when I look at this, how do we start these area of regular polygon problems? We always start by drawing this into 6 equal triangles because we have 6 sides. And we know that every single one of these central angles will always add up to be 360 degrees. And ask yourself, what is 360 divided by 6, the number of 1, 2, 3, 4, 5, 6 sides of this polygon? Well, 360 divided by 6 would give us 60 degrees. Now this in turn allows us to draw our right triangle here, and let me begin by drawing it right here separately so it's easier to see. We know that we have our apothem of 12. We know we have our missing side of x, which will allow us to find the perimeter later on. And lastly, you have to ask yourself, what is the angle that should go here? Well, remember, the apothem always cuts the central angle in half. So we can do half of 60, which will in fact give us 30 degrees. So now that I have my right triangle, and I have my opposite side, and I have my adjacent side, let's go ahead and fill in our tangent function, which is still the same function that we've been using. So we'll use tangent of 30 is equal to the opposite x over 12. Now how do we start these trigonometric functions off? Well, we always start by multiplying what's in the denominator. So we'll multiply both sides by 12, which this is such a simple case because on this right side we now have the x by itself. So what is 12 times the tangent of 30? And it actually turns out to be 6.93. And that's our x value. However, that is not our answer. So we have 6.93, and we know that that is a portion of this side. Well, to get this whole side DE, we have to take and multiply that by 2. And 6.93 times 2 will in fact give us 13.86. And if I want to find the perimeter, well, I know that this whole side is 13.86. We simply have to do 13.86 times 6, which will in fact give us the perimeter of 83.16. And that is, of course, going to be in inches. Well, now that we have our perimeter, we can take and plug it back into our formula. And let me just rewrite our formula right here. A equals 1/2, parentheses, the apothem of 12 times the perimeter, 83.16. And when we multiply all of that together, we get, well, let's see what we get. Let me grab my calculator. Times 12 times 0.5. We get 498.83 inches squared. And this will, of course, be the area of our regular polygon. Well, I hope these 2 examples helped, and good luck.